So we're going to begin our talk today on experiments and how to conduct them and on graphing by looking at a very simple example. In this case, we're going to look at our garden. And we've noticed that in our garden that some plants grow better than others. We've made this observation. We have some ideas about why that is. And we come up with a reasonable explanation. So we suspect that some plants are growing better because some plants are better fertilized than others. Well, now that we've asked that question why and we've answered it, what we've come up with is our hypothesis. Our hypothesis is just that reasonable explanation for the observation we've made. So in this case, we suspect that if we add nitrogen in the form of fertilizer, our plants are going to grow better. And in fact, that's why some plants in our garden are growing better than others. Now, this leads us to what is a hypothesis. Now, you've probably been taught that a hypothesis is an educated guess. I don't want you to use that term because it implies that it's a guess. It is not a guess. We do not make guesses in science. So a hypothesis is much more specific than a guess. First of all, it's a reasonable explanation. It's an explanation for whatever we've observed. In this case, that nitrogen is causing increased plant growth. It's also a testable statement. If you can't test it, it's not a hypothesis. So if you make the hypothesis that, say, fairies are coming at night and sprinkling fairy dust on some plants, making them grow better, that's not testable. And so in that case, it's not a hypothesis. It also asks why or how. So this is a classic example of how people are natural scientists. So whenever you hear somebody say, why is that? What they're actually doing is making a hypothesis with the answer. The answer to that question is going to be your hypothesis. Now, I'm going to put this last one as that it's an if-then statement. And the reason I'm going to do that is because if you couch your hypothesis in that format, then automatically it's going to become testable. And it's going to help you to make it a testable statement. Classic scientific method. The steps usually go observation, hypothesis, prediction. I'm going to collapse that hypothesis prediction step. And I'm going to say that if you make your hypothesis into an if-then statement, it's automatically a prediction, and a prediction is testable. So putting our hypothesis into an if-then statement is going to be if nitrogen is the limiting nutrient for a certain plant community, say those plants in our garden, then adding nitrogen will lead to an increased growth in the plants in that community. Right now, that's really testable. It's very easy now for us to set up our experiment. When we set up an experiment, we're going to have a control group, always. So your control group is going to be the group where you have no special conditions. It's just normal conditions. It's whatever you naturally find it in. It's just going to be your garden plants. You're not going to add anything. You're not going to subtract anything. You're just going to have the garden the way you normally have it. And you're going to have a treatment group. Now what you're going to manipulate is one variable only, in this case nitrogen. So in your control and your treatment group, they're exactly the same, except your treatment group, you've changed the amount of nitrogen that's being added to it. That's really important that you just change one variable. I want to take a step back into what this word variable means. It's often used and a lot of people can't really explain it. A variable is some factor that has changing amounts. So it's variable. So in this case, there's variable amounts of nitrogen and there's variable amounts of plant growth. So they're both variables. So in this case, our treatment is going to be the group with the added nitrogen. When we set up our experiment, we're going to randomize how we set it up. And the reason for this is to eliminate bias. We're going to talk about bias later on. So in our control groups, we just keep them the same. And in our treatment groups, we add nitrogen, a certain amount of nitrogen that we've measured out. We know what we're adding. Well, here's our hypothesis again. If nitrogen is a limiting nutrient for a certain plant community, then adding nitrogen will lead to increased growth of the plants. So if that is correct, what do you think our graph is going to look like? Now this is going to be really important for graphs. When we look at graphs, we're going to have on the graph both an independent and a dependent variable. And I just want to say that no matter where you are in the world, it's going to be the same. Your independent variable is always going to be on your horizontal axis. Always. When you look at a graph, you're always going to look at it and say the independent variable is on the x-axis. It will not change. There are exceptions when some people make their graphs go on their side, but still, it's always that axis. The dependent variable is always on the vertical axis. Always. It's not going to change. Now, sometimes you may get confused depending on what the variable is. But what you have to understand that independent variable is whatever the treatment is, like whatever we've set as the experimenters. The dependent variable is whatever is dependent on that variable. So in our case, we have nitrogen and we have plant growth. Those are our two variables. Which one is dependent on the other? So our independent variable, which is the one we set as the experimenter? Nitrogen. So we've added amount of nitrogen. In this case, I'm going to make that amount of nitrogen quite variable. Our dependent variable now is that variable that's dependent on the independent variable. In this case, what's dependent on the amount of nitrogen you add? Well, plant growth, whatever measure of plant growth that you're doing. So what would the actual results look like if our hypothesis were true? And the way that you're going to say this is, if I increase my amount of my independent variable, what happens to my dependent variable? If I increase the amount of nitrogen added to the plants, what do you think is going to happen to the plant growth? Just have to look at your hypothesis for that answer. If our hypotheses are true, our expected results would be, if we increase the amount of nitrogen, we're going to get an increase in the amount of plant growth. Don't confuse the two. I don't want to hear you ever say that if we increase the plant growth, we're going to get more nitrogen. And that may sound silly, but it actually does matter, and it's not always going to be that cut, dry, and simple. So always remember, we start with the independent variable. As we increase the independent variable, what happens to our dependent variable? Does it increase, decrease, or does it stay the same?